Okay, in this video, we'll be going over part 4 of the Georgia Milestone Study Guide. It's the geometry unit, which is unit 4, and we'll be covering numbers 7, 11, 13, 16, 24, 27, 34, 35, 37, and 42. So let's get started with that. Number 7 says, what shape is formed by the intersection of the right square pyramid shown in a plane parallel to its base? Okay, so this is a cross section. So we have a 3D figure, it's a square pyramid, and a plane has come and cut it, and then it wants to know what shape would we have that would be here, okay? And we can see that it is a square. So triangles out square. A rectangle that is not a square, well, my sides are going to be all the same length since my base is 5 inches and 5 inches. All of my sides here are going to be the same length. So it cannot be a rectangle that's not a square. So it has to be exactly a square. So B would be the correct answer there. Okay, for number 11. Says point C is located 8 inches from point A and 6 inches from point B. Points A and B are 2 inches apart. Which statement is true? So we're looking to see if the points cannot be connected to form a triangle. If we can get one triangle or two triangles or more than two triangles. Okay. So remember, if we can form a triangle, we have to have two of my smallest side lengths has to be greater than my third side length. Okay, so my side lengths are 8 inches, 6 inches, and 2 inches. Okay, so remember you circle your two smallest numbers, so that would be 6 and 2, and you add those together. 2 plus 6 has to be greater than 8. 2 plus 6 is 8, and then so you see, is 8 greater than 8? Okay, that is not correct. So then that means we do not have a triangle. So my correct answer there would be A. Okay, moving on to number 13. Says Lacey is building a plant stand. To understand how much wood stain to buy, she needs to determine the surface area of all the outside faces of the stand. She will not have to apply stain to the area where the two pieces of wood meet or to the bottom of the stand. Okay, so I don't have to find that surface area of those parts. What is the surface area of the plant stand that Lacey will stain? Okay, so let's start with our top piece first. Okay, I'm going to find the surface area of this whole prism here. Okay, so remember you can set it up as a table here, top and bottom, front and back, left and right. Okay, and then in this case I'm working with a rectangular prism, so I have all rectangles. Okay, so for the top and bottom sides, my dimensions are, if I look at the width here, would be 30, the same as here. So this side is 30, and my length is also 30. So it'd be a 30 by 30. Okay, from my top. Now the bottom, see how I have the overhang here? So I'm going to go ahead and find the surface area there too. So it'd be 30 by 30 as well. Okay, for my front and back side, will be this side facing us here. So the height here is 5 and the length there was 30. So my dimensions would be 5 times 30. There's a front and a back, so there's 2 of those. And then I have a left side and a right side. Here I can see the right side. The height is 5 and the width there is 30. So it also measures 5 by 30. Okay, so I'm going to find the surface area, the areas of all these rectangles here to use for the surface area. So if I multiply 30 by 5, I get 150. And 30 by 5 gives me 150 again. And then 30 times 30 gives me 900. Okay, so that's for my top piece. Now for my bottom piece here, I'm going to do the same thing. Top and bottom, front and back, left and right. Okay, so I've got a top and bottom rectangle, a front and back rectangle, and a left and right rectangle. Okay, for my top and bottom, that's what it's sitting on here, and then what it's connected with at the top here. All right, now those dimensions are 20 by 20s, okay? But since I'm not going to put any stain here, I don't have to find the area of those. Okay, so I don't need those. Front and back would be the side facing us here. So the length would be 60 and the width would be 20. So it's a 60 by 20. I'm going to need both of those. And for my right side and my left side would be this side here. So it is also a 60 by 20. Okay, and 60 times 20 is 1200. 6 times 2 is 12, and then add your 2 zeros there. Okay, now to find the surface area, I'm going to add all of these together. Okay, so you add 1200 and 1200 is 2400, plus another 1200 is 3600, plus another 1200 is 4800. So just for this area of the bottom piece, I've got 4800. Okay, then if I add my left and right side, 150 plus 150 is 300. Okay, plus another 150 is 450, plus another 150 is 600. Okay, so therefore I got um, six. I've got here. I've got 300, and here I've got 300. Okay, so when I add those two together, I'll have 600 total here. Okay, and then I have to add in. I have to add in my top and bottom, so two 900s a piece. So that would be 1800. Okay, so 1800 plus 600 is 2400. So my surface area would be 2400. Okay, so if I add these two together, 2400 plus 4800. Okay, 4800 plus 2400 gives me 7200. Okay, now I have to take out where this top piece overlaps here. Okay, so I'm going to take out this area. Now it's not the whole bottom piece, it's just the same area as the top. So my top area was a 20 by 20, which was 400. So I'm going to take out 400 from here. So I'm going to subtract 400. So 7200 minus 400 leaves me with 6,800. So my total surface area of where she's going to put the stain is B, 6,800 centimeters squared. Okay, so don't forget, after you take out the top and bottom, you also have to take out the bottom of this piece that's touching here, which was a 20 by 20, which gave us 400. Okay, so we got to subtract that from our total surface area. Okay, our next problem is number 16. It says, what is the measure of angle Y? Okay, so I need to talk about some angle relationships here. I see this angle is 125. This angle here is a right angle, so that means it measures 90 degrees. Okay, so then we're going to talk about either vertical angles. I'm going to talk about I'm going to talk about supplementary angles, or I'm going to talk about complementary angles. Okay, so complementary angles, they add together to give me 90 degrees. All right. Um, vertical angles are straight across from each other. They have the same measure. Supplementary angles, I add them together to get 180 degrees. So I can say that this angle here is 125 degrees. Okay. Well, if I take this angle and I flip it over, okay, if I flip it right over, then it's going to be the same as these two angles together. This 90-degree angle plus this angle y here, okay, which I'm trying to find the measure of. So if they're vertical from each other, that means they're going to be the same measurement. So I know that y plus 90 is going to equal 125 degrees. Okay, so now I've just made an equation and I have to solve that equation. So I'm going to subtract 90 from both sides. That side cancels, and 125 minus 90 leaves me with 35. So y, angle y, is 35 degrees. Okay, so for number 24 is our next one. Number 24 says, what shape is formed by the intersection of a sphere and a plane? Okay, well, a sphere is a 3D circle. Okay, so picture a 3D circle, which is almost impossible to draw here. But picture a 3D circle and a plane or somebody slicing it in two. Okay, so what shape is going to result from that? If I slice it straight across, I'm not going to get an oval. Definitely not going to get a parallelogram. Not going to get a square either, so the only cross section that would be left is a circle. Okay, so when I take a sphere and I slice it, and I open it up on the inside, I'm going to see a circle. So C is the correct answer there. Okay, our next one is number 27 here. Number 27 says, Alan wants to wrap a piece of colorful tape around a cylindrical vase that has a radius of 3.5 inches. What is the minimum length of tape that he will need? Okay, so he's got a cylindrical vase, so it's like a circle was the opening, okay? He wants to wrap a piece of colorful tape around it. So if he's going around the outside here, that would be circumference, okay? So I need my circumference formula. Circumference equals 2 pi r. Okay, remember our little song, twinkle, twinkle, little star, circumference equals 2 pi r. Okay, and then it tells me that I need to use 3.14 for pi. All right, now so I'm going to put that in my formula, and also tells me my radius is 3 5/10 inches, or 3.5 inches there. So here's my radius. Okay, so now I have everything I need to plug into my formula. So I got C equals 2 times pi, which is 3 14/100, and then times my radius, which is 3 5/10. Okay, now remember, I can use the calculator on this section of the test. It's the geometry section. So if I plug it in my calculator exactly like I have it there, 2 parentheses 3 14/100 times 3 5/10, all like that, exactly like that in my calculator, and hit enter, then I get 21 98/100. So my circumference is 21 98/100 inches, which is C. Okay, so remember, circumference is just like the perimeter. It's the distance around the outside of a circle. Our next problem here is 34. Patrick recently purchased a piece of property where he can build a house. The property is next to a road, so the property can be represented by a rectangle and a right triangle as shown. Okay, so here's my rectangle on the bottom. Here's my right triangle here on the top, connected to the road. So my question says, before Patrick can build his house, he needs to know the total area of the property. What is the area of the property? So I'm looking for area. Okay, well, I've got two different shapes here. I've got a rectangle and I've got a triangle. So I need two different area formulas. So my rectangle area is length times width. My triangle area is base times height divided by 2. Okay, so let's start with a rectangle. Okay, that seems to be the easiest one. So my length, okay, is my long line here, so that's going to be 100 times the width, which is my shorter line here, which is 60. Okay, so when I multiply 100 times 60, then that gives me 6,000. So I get 6,000, and it's in feet, so it's going to be feet squared. Okay, don't forget about your units there. Now my triangle at the top. Okay, I've got base times height divided by 2. Okay, my base measurement is what it is sitting on. Now remember I told you in a right triangle, this right angle will connect your base and your height. Okay, well 45 would be my height, so my base would be this line down here on the bottom. Okay, well this dotted line is the same as this line down here at the very bottom, which is 100. So it would be 100 times my height, which is 45. And then I'm going to divide that by 2. Remember, when we're looking for base and height of a triangle, we never use a slanted line. So see this slanted line here? It gives me the measurement, but I don't need it. Okay? I don't use that for the area of a triangle. So I'm going to multiply 100 times 45, which gives me 4,500. And then I'm going to divide that by 2. And when I do that, my area is 2,250 feet squared. So this one is 2,250 feet squared for the triangle. For the rectangle was 6,000 feet squared. Okay, so I want to know the total area. So to find the total area, I'm going to add 2,250 plus 6,000 together. And that's going to give me 8,250 feet squared, which is 8. Okay, be careful on your triangles. Never use slanted lines to find area. They're going to try to trick you that way. Okay, let's look at 35. It says Abel is an architect designing a new art museum. He wants to include a circular gallery with a circumference of 52 meters. He calculates that the area of the gallery's floor will be about 861 square meters. Is Abel correct? So we're going to see if he's either correct, or if he's not correct, what is the actual square meters. Okay, so first of all, we know that we're going to have a circular gallery, so we're going to have a circle here. Okay, the only thing we do know about this is that my circumference of this whole circle is 52 meters. Okay, so with that, let's scoot this over a little bit. Remember, my circumference equals 2 times pi times my radius. Okay, well, I'm going to plug in what I know. The only thing I know is that the circumference is 52 meters. Okay, so 52 is my circumference equals 2 times pi times my radius. Okay, well, I need to figure out what the radius is here. So I'm going to get r by itself. So that means I have to get rid of 2 and the pi. So I'm going to solve this equation here. So I'm going to divide both sides by 2 first. That gets rid of my 2's here. So I have pi times my radius equals 52 divided by 2 gives me 26. Okay, now I still got pi and I still got my radius here. I'm trying to get radius by itself, so I need to get rid of pi. So I'm going to divide both sides by pi, which is 3.14. So I'm going to divide both sides by 3.14. Okay, when I do that, and it cancels out here, so I get my radius, and then 26 divided by 3 and 1400ths. Now I get a long decimal. It's 8.280254, and it keeps going. So I'm going to go to 2 decimal places. Since pi's in 2 decimal places, I'm going to round to 2 decimal places. So it's going to be 8.2800ths. So my radius is 8.2800ths meters. Okay, now why did I need to find my radius? Is because we're talking about the area. Okay, now remember my area formula for a circle, area equals pi times my radius squared. Okay, so I have to know my radius in order to find the area of a circle. So now I have my radius, I can plug in what I know. For pi, I'm going to use 3.14 times my radius, which is 8.2800ths, and it's going to be squared. Don't forget your little squared there. Okay, and you're going to put it in your calculator just like that. Okay, so I've got 3 and 1400ths times 8.2800ths. Hit the squared button right here by the 7. It says, move it up so you can see here. Right here by the 7 is squared. Hit that button, close your parentheses. Okay, it's exactly like I wrote it here on my paper. So I'm going to hit enter, and I'm going to round this to 2 decimal places. So my area is 215 and 27, because there's a 3 after the 7, so my 7 is going to stay the same. And that's in meters squared. Okay, so is he correct? No, he said it was 861 square meters. We got 215 square meters. So is he correct? No, so it's either B, C, or D, and we're looking for around 215 meters squared. So our correct answer there is B. Okay, so our next one is number 37. And it says Aaliyah draws a sketch for a poster she's designing. To draw the design using her computer program, Aaliyah needs to know the measure of the angles in the shape. So what is the measure of angle Y? Okay, so here's the angle Y out here on the outside. So if I look at angle Y, I can tell it's a large angle. Okay, it's very wide here. So I know it's going to be an obtuse angle. So since it's obtuse, it's going to be greater than 90 degrees. So I can go ahead and get rid of A and B. I know they're not going to be the correct answer because both of those are acute angles. Okay, so if you look at this bottom shape here, you notice that it's a triangle. Okay, well in a triangle, it has to add up to 180 degrees. So to find out what this angle is, I could add 70 and 60 together and get 130 degrees. Okay, so to find out how much this angle would be, all three of them together have to be 180 degrees. So I take 180 and subtract 130 from it. That leaves me with 50 degrees. Okay, so this angle is 50 degrees. Now I'm trying to figure out how much angle Y would be. Okay, so I see that angle Y and this angle together, angle Y and this angle together form a straight line. It runs from here all the way to here. Okay, so if they form a straight line, that means they're supplementary angles, which together they add up to be 180 degrees. Okay, a straight line or a straight angle is 180 degrees. So if this one is 50 degrees, I could take 180 and subtract 50 degrees from it. And 180 minus 50 leaves me with 130 degrees. So angle Y is 130 degrees, which is letter D. Okay, now our last problem, number 42, has multiple parts to it. So it starts with part A on this page. The park manager is planning to add a fish pond to a state park. The figure below is a scale drawing of the fish pond. Its scale is half an inch equals 15 meters. Okay, and so obviously this is not drawn to scale, and I'm going to have to figure out first what is the area of the actual fish pond, and I'm going to use 3.14 for pi. Okay, and I need pi because here I have a half a circle on each side, so that means I have a circle total between the two. All right, now it told me to show my work and write your answer down here. Okay, so first of all, I need to figure out how big this thing really is. So if my scale is 1/2 inch equals 15 meters. Okay, remember when we have a scale, we're gonna set up a proportion. So my proportion would be 1/2 inch. Okay, I'm looking at inches to meters here. That's what they gave me, inches and meters. So half of an inch is 15 meters. So I'm going to figure out if I have 1 whole inch here, how many meters that would be. Okay, so I'm going to cross multiply. So I get 1/2 x equals 15 times 1 is 15. Now I'm going to divide by half. Now remember, I can't divide by a fraction, so I'm going to multiply by its reciprocal. So I'm going to multiply by 2 over 1. This side cancels, I get x. I'm going to put 15 over 1 to make it a fraction and just multiply by, straight across. 15 times 2 is 30. 1 times 1 is 1. So 30 over 1 equals 30. Okay, so this is going to be 30 inches actually. So I'm going to do the same thing to find the length of my rectangle down here. I found the width, now I need to find the length. So again, I'm going to do inches to meters. Going to use my same scale. 1/2 inch equals 15 meters. And I'm looking for this length here, so that would be 2.5 inches is some number of meters. Okay, that's what I'm looking for there. I'm going to cross multiply, so I get 1/2 x equals 15 times 2 5/10, which gives me 37 5/10, or 37.5. Okay, and then I'm going to multiply both sides by 2/1. Okay, this side cancels and I get x. Now here I have a decimal times a fraction. Okay, you can change this to 37 5/10. You can change it to an improper fraction. You do have your calculator. You can put it in that way. 2/1 is 2. Okay, so really this is 37.5 times 2. And you can definitely multiply 37.5 times 2, which gives you 75. So that would give you 75 inches actually, or 75, excuse me, this should be meters. Okay, this should be meters. So it would be 75 meters. Okay, now to find the area of the actual fish pond, I've got two different shapes here. I've got a rectangle in the middle, and then I've got half a circle on each side, which if I put two halves together, then I get a whole circle. Okay, so I'm going to start with the area of my rectangle. So my rectangle area, remember, it's length times width. Okay, so for my rectangle, the length is 75 meters times the width, which is 30 meters. So my rectangle area is 75 times 30, which gives me 2,250 meters squared. Okay, now I have to find my circle area. Now remember, for a circle area, I get pi times my radius squared. Okay, so for the circle area, pi, it tells me to use 3 1400 times my radius. Now radius is half of a circle. Okay, half of the diameter of a circle. So from the middle out. Okay, well halfway, I don't know what half of it is, but I know this whole thing is 30. So to find half of it, I'll take 30 and divide it by 2. Okay, and then that gives me 15. So my radius, half of this, is going to be 15 meters. So I'm going to do times 15 squared. So then I've got 3 1400 times 15 squared, which gives me 706 5/10 meters squared. Okay, so to find my total area, I'm going to add those two together. 2,250 plus 706 5/10 gives me a grand total of 2,956 5/10 meters squared. And I would write that up there where they wanted me to put my answer. Okay, and so I wrote my answer, and I have shown all my work of how I got that answer. Okay, this is what they're looking for. What formula did you use? What numbers did you use? Where did those numbers come from? Okay, and then what the total area is. So if they give you a box here, make sure you're putting your work in your box and showing your work. Okay, for part B. Says the city will build a low fence around the entire fish pond. What is the length of the fence? And use 3.14 for pi. Okay. Well, if I'm putting a fence around something, that means I'm putting around its perimeter. So I need to find the perimeter. Okay. So I'm going to put this down here on the bottom where we can see our measurements again. Okay, so I need to find the perimeter. Well, I've got two shapes. I've got a rectangle and I've got a circle. Okay, to find the perimeter of a rectangle, I add all of its sides together. Okay, remember we got different methods. We got the walk around method, we've got adjacent sides, and we got 2 lengths plus 2 widths. Okay, walk around method is easy to make sure we have all the sides. Okay, now with this fish pond, we're only going to do the outside. So from here, if we start here, all the way around back to this side. Okay, so I don't need these sides here. Not going to count those. Okay, they don't matter because they're not going to have a fence around them. So my perimeter for my rectangle would just be 75 from the bottom plus 75 from the top. Okay, now to get the perimeter of a circle, remember that's the distance around the whole outside of a circle, I'll use circumference. Circumference equals 2 times pi times my radius. So circumference equals 2 times, I'm still going to use 3 and 1400 for pi, times my radius, which we said was 15. Okay, now since I have 2 half circles, a half over here and a half over here, if I put those together, that makes a whole circle, so I'm still going to use the whole formula here. Okay, so 2 parentheses 3.14 times 15 gives me 94. The circumference is 94 and 2/10. Okay, so for my square over here, I got 75 plus 75, which gives me 150. Okay, so to get the total perimeter, I'm going to do 150 plus 94 and 2/10, which gives me 244 and 2/10, and that is in meters. Just regular meters. It is not squared. We're just adding up all the sides that we need. So I get 244 and 2/10 meters. Okay, so for part C, it says after the pond is created, a runner jogs 3.5 laps around it. How many meters does a runner jog? Okay, so for part C, it says after the pond is created, a runner jogs 3.5 laps around it. How many meters does a runner jog? Okay, well, when you're jogging, you're running around the perimeter. Okay, runner's going to jog around the outside of this pond here. Okay, so he's going to go the whole thing, so it would be the same as how much fence I need. So for the perimeter, remember the perimeter was in part B here, 244 and 2/10 meters. Okay, so if he's jogging around this once, he's going to do 244 and 2/10 meters. Okay, now since he's going to do 3.5 laps around it, that means he's going to jog 244 and 2/10 times 3. He's going to do that 3 times. So all I have to do is multiply 244 and 2/10 times 3, which tells me he's going to run 732 and 6/10 meters. So my answer is 732 and 6/10 meters. Okay. Oh, sorry, we just did that wrong. This should be 3.5. So 244 and 2/10 times 3 and 5/10 meters gives me 854 and 7/10 meters. 854 and 7/10 meters. Okay, so always go back and double check yourself. I looked that again, and it was 3.5 laps. So I have to make sure I multiply that by 3 and 5/10 or 3.5 there. Okay. All right. Let's look at part D. Our last section, our last part here. It says a duck swims in a straight line from one end of the pond to the other between the points on the edge of the pond that are the farthest apart. How far does this duck swim? Okay, well, here's my duck here, okay? He's gonna swim from here all the way across the pond to here. All right, from the farthest points All right, so that means he's traveling this distance straight through. Well, from here, from the middle of my circle out, half of this circle, remember we said was 15 meters. That come from my radius of my circle. So he's going to swim those 15 meters plus the whole length of this rectangle, which was 75 meters, plus the last radius of this circle, which is another 15 meters. Okay, so he's going to swim that whole length, and if I add those together, 15 plus 75 plus 15 gives me 105. So the duck is going to swim 105 meters. Okay, and then that is the last problem for our geometry unit.